Well, welcome back from the break, teachers. It's MathFix time. Let's explore this week's problem, possible student discussions, and solutions. Our problem this week looks at standard 6.g.1, which has students finding the area of right triangles, some other triangles, special quadrilaterals, and polygons by composing them into rectangles or decomposing them into triangles and other shapes. Well, this week we're looking at a composite shape that appears to be made up of several other shapes that students are already familiar with, like triangles, squares, and trapezoids. This question, though, isn't about finding the area of the entire shape, but rather evaluating which of the given formulas would work for the entire shape. These formulas should be somewhat familiar, but it could also be quite possible that without context they are unfamiliar with what exactly the shape that they are looking for. This is actually part of the intended discussion for this problem, so try not to give them any additional information unless they seem completely stuck. In identifying the formula measures what shape, students should be discussing what the letters represent and what elements of the formulas are clues for which shape they are looking at. They can also be discussing some of the relationships between the formulas and the shapes, or shapes among other shapes too, like the triangles that are half of the quadrilaterals, or squares are special quadrilaterals with the length and widths that are the same. Trapezoids are made up of rectangles and triangles, all sorts of relationships there. Well, the answer to this problem is actually that all three formulas could be used for the sole method for solving the total area. However, the easiest formula might be the length times width quadrilateral formula because it is the most general one, and through decomposing or small rearranging, we can get all of the components of the shapes into quadrilaterals. The triangular formula might also work. We can compose a lot of the shapes into triangles, but the square formula might be the most difficult, still possible, because we'd simply have to cut up the shape into a lot of little tiny squares. Well, we welcome any feedback you have on this or any of our other math fixes, and please let us know your thoughts and students' conversations or classroom experiences in the comments below.